Good morning, students. Today we'll discuss about sorting techniques. So what is sorting? Sorting is the process of arrangement of data in order. So there are a lot of sorting techniques which are available in the market. So a few of them include bubble sort, selection sort, insertion sort, merge sort, quick sort, radix sort, heap sort, counting sort, etc. So the process of putting data in order that can be either in increasing order or in decreasing order is known as sorting. So we'll take up one of the very prominent sorting techniques called the selection sort today and look at how does it work and how to implement it, and we'll probably try and execute the program to check out how it works. Okay, so let us start today. So here we go. Sorting. Sorting is an arrangement of data. It can be in any order. It can be numerical order, ascending, descending, etc. So selection sort. How does selection sort work? As the name says, selection is choice. You tend to make a choice and then sort the elements. So if I break selection sort into two words, selection is choosing and sorting is arrangement. So the process of arranging data by choosing and then keeping it up in its right order, and that's how sorting out all the elements in the list is known as selection sort. So selection sort totally takes n-1 passes, where n is the list, where n is the length of the list. So therefore, imagine, for example, let us consider a list containing 6 elements: 23, 78, 45, 8, 32, and 56. So in this case, how does selection sort work? So selection sort essentially works in two phases. Step 1 is finding out the minimum element in the list. Step 2 is swapping that minimum element with its right place. So therefore, in this list, if we consider 8 seems to be the smallest element, so therefore pick up 8, swap it and put it in 23. So therefore now the list becomes 8, 78, 45, 23, 32 and 56. Now the list breaks into two parts. The blue line here indicates how does the list broke into. So the list has a sorted element in the first part and all the other remaining unsorted elements in the next half of the list. So therefore, now repeat the same process of picking up a smallest element and swapping it with the first place for the remaining unsorted list until the unsorted list has just one element. So therefore, like this, if we go on, the final list becomes 8, 23, 32, 45, 56 and 78, and that's how the list gets sorted. So now let us see in detail what is the algorithm of selection sort, or the pseudocode that works for selection sort. So it works the following way. So find the minimum element in the list, choose the minimum element, swap it with the element in the first position. Now, at this point of time, you call it as pass 1, where the smallest element reaches its place. Then repeat the same steps until all the elements are sorted. All the elements get sorted when there is only one element remaining in the unsorted list. That's obviously the largest element of the list. So therefore, repeat this until all the elements are sorted. For example, let us run this program with 6 elements. Yeah, this is how it looks. 8, 78, 45, 23, 32 and 56. This is when my program just got executed. So on this note, let us take up some code which gives you. So well, let's continue. Let's see a code that implements selection sort this way. So how does the selection sort gets implemented? So this is the program that checks out how to implement selection sort. So yes, you read your elements because you need an array A of n elements. So n is my size of the list, and then you read your elements. Then you continue. Selection sort essentially takes n-1 passes. So therefore, you start with 0, I less than n-1. You assume that your first element is smallest. If you find any other element which is smaller, any a of j which is smaller than what you assume to be a of min, you update your min to be j. So that's how the entire inner loop gets you to the smallest element. After that, if your smallest element position and the position of the smallest element is not same, then swap your elements. So that's how, after this, that's how the process gets printed. This is the logic that essentially implements selection sort. So let's try to run this code and understand how the selection sort basically works. So let's write a C program that implements selection sort. So this is a C code that probably helps you to understand how does it work. So here is a program. This is selection sort. So n is the number of elements. Then read your elements. This is how selection sort works. It totally takes n-1 passes. So the first loop always talks about number of passes. assume that the smallest element position is I, that is the first place, then continue to search for the smallest element in the remaining list. So when I assume that the smallest element is in the first place, implies you're continuing from the second element in the list till the end of the list. So j goes from I plus 1 to j less than n. If you find any element a of j which is lesser than a of min position, or in other words, you can write this way. So if you find any a of j that is lesser than a of min position, then you update your min position to j. So therefore implies that at j is the smallest element which is lesser than what you assume it to be there at the start. So at the end of this inner loop, you are ready with your smallest element. So the inner loop is essentially to find out the minimum element in the list. So selection sort basically works by finding out the smallest element, find out the min element position. So this is used to find out the minimum element position. Then you will find out the pass. So at the end of each pass, one smallest element, the smallest element of that particular list reaches its place. So this is how it is. This is how the program. So let us save it, compile to check if there are any errors, and run the code to check how does it work. So enter number of elements. Say for example, let us take 7, 2, 7, 1, 9, 0, 3, 5. Okay, this is the element. So the smallest element seems to be 0. So 0 is picked up and swapped with 2. So at pass 1, it becomes 0, 7, 1, 9, 2, 3, 5. So now the sorted element reaches its place. So continue with the remaining unsorted elements in the list. And the remaining list, smallest element is 1, which is swapped with 7. The rest elements as it is. So next in the remaining list, next the smallest element is 2, which is swapped with 7. So it becomes 2, 9, 7, 3, 5. And again, the next smallest element is 3, swapped with 9. So 3 and 9 get swapped. Then the next smallest element is 5, which is swapped with 7. So the now next it is 7, which is swapped with 9. And finally at pass 6, because they were given 7 elements, it takes 6 passes and minus 1, which is 6. And the sorted list is 1, 2, 3, 5, 7, 9. And this is how the selection sort works. So if we got to talk about the complexity of selection sort, yes, selection sort essentially has two loops. One loop that runs for n minus 1 times because it indicates n minus 1 passes, and the inner loop which continuously checks n elements at the start, n minus 1 in the second phase, n minus 2 in the second phase, and so on. So it runs for n times essentially to check out the smallest element. So therefore, in general, if we have to talk about the time complexity of selection sort, the outer loop runs n times, or in other words, n minus 1 times, n minus 1 times. If n is too large, you can always treat it to be n times. Then the inner loop runs for n minus 1 times, then it is n minus 2 times, then it is so on 1 time. Implies it also runs n times. So therefore the complexity is n into n, therefore it is n square times. So the complexity of selection sort is n square. Selection sort do not require any extra space, so therefore its space complexity remains to be constant, and its time complexity is order of n square. And its time complexity is order of n square. So it takes n square iterations, or it works in terms of n square. If we have to compare selection sort with bubble or insertion, the one thing that selection sort clearly is, selection sort only takes one swap per pass compared to over bubble sort. Bubble sort might require more passes per each swap, but selection sort only requires one swap per pass. But selection sort every time requires comparison of all the remaining elements of the unsorted list, whether the list is sorted or the list is unsorted. So therefore it is difficult to predict if the list is sorted in between selection sort. Even the input is 1, 2, 3, 4, 5. Selection sort obviously requires n square iterations. Even the list is 4, 5, 3, 2, 1. It also requires those many iterations. So therefore, selection sort space time complexity in best, worst, and average cases is always n square. But its space complexity remains to be O of 1, which is constant. So let's once take a time to just revise what does selection sort mean. Selection sort essentially means selecting the smallest element in the list and replacing it with positions. So finally, selection sort requires n square passes. So the best, worst, and average case complexities of selection sort is n square, and the space complexity of it is O of 1 because it does not take any extra space. So thank you.